So hi everyone and welcome to Airflow Summit 2020. Roy and I are very excited to be here and to share our journey with Airflow with you. But before we start, I want to tell you why you would like to stay and listen to our presentation, or basically what's in it for you. So you can see we have two DAGs here. They are pretty much similar. They're actually running the same application with a few minor modifications. However, they are significantly different because once we switched from the left-hand side DAG template to the right-hand side DAG template, we were able to reduce our cost by about $30,000 a month. It opened our eyes and gave us better visibility and made our systems more robust. And today we're going to share with you how we did it. So how exactly? By migrating Airflow-based Spark jobs to Kubernetes the native way. So now we can officially start. So my name is Itai. I'm a tech lead of a big data group within Nielsen, and I've been dealing with big data challenges since 2012. Co-speaking with me today is Teveth, who's a big data developer in our group, and he's also a Kubernetes evangelist. You can reach us both on Twitter and LinkedIn. So what will you learn today? You learn that Airflow is awesome, and you will love it once you use it. We'll talk about ETLs with Airflow and Apache Spark, and of course we'll talk about what is Spark for those of you who are not familiar with it. We'll then cover Spark on Kubernetes and some basic terminology for Kubernetes. And lastly, we'll talk about how we integrated everything with Airflow and contributed that back to the open source project. But the most important thing you learn today is how to leverage all that in your organization. So just a little bit about the Nielsen Identity Engine, which is the division Roy and I work for. It's based on the acquisition of a startup called XL8 by Nielsen, the data and measurement company, a few years ago. We are a data company, which means we collect device-level data from around the internet. Device can be smartphones, tablets, smart TVs, etc. We then run machine learning models on top of that data to enrich it and to provide our customers, which are marketers and publishers, insights on the data. We allow them to better target their audiences and to make better business decisions. So some numbers about us. We are, as I mentioned, a data company, so we have a lot of data. We ingest about 30 terabytes of compressed data every day into our data lake. So that adds up to a few petabytes in total. We run about 3,000 nodes of Spark every day, and we ingest tens of terabytes of data into Druid, which is our OLAP database, every day. And finally, because we reside on AWS, our AWS monthly bill is a few $100,000. So you can understand it's quite a significant infrastructure that we maintain. So the challenges of such an infrastructure are many, but those are the major ones. So scalability, fault tolerance, and cost efficiency. So why did we need Airflow to begin with? So we have dozens of ETL workflows running around the clock. Originally, we used AWS Data Pipeline for workflow management. However, we also wanted better visibility of configuration and workflow. We wanted to have better monitoring and statistics. And finally, we wanted to be able to share common configuration and code between workflows. So why do we love Airflow? Well, Airflow met all those requirements and more. We've been using Airflow in production for the last 2 years, and there are about 40 users across 4 groups writing various DAGs. We have about 1,000 DAG runs per day, and we also use Airflow as part of our CI/CD, so we have about 20 automatic DAG deployments per day. And in these 2 years, we were able to contribute 6 times to the Airflow open source project, and we'll elaborate more on that later. So remember this slide. As I mentioned, it's a rather simple DAG. It's basically a simplified example of a very common pattern of ETL for us, an ETL or a data pipeline. If we focus on the left-hand side DAG, you can see we have 3 Airflow components, 2 operators, and a sensor, and I'll elaborate on each of those later. But I want to show you this common data pipeline pattern from the architecture point of view. So from left to right, we usually have our data lake, which is, as I mentioned, S3 based. And we have a data processing layer which read input files from that data lake, process the data, and write output files to an intermediate storage, which is also on S3 buckets. From there, we ingest the data to our OLAP database, which is Druid. Now, if we focus on the data processing layer, you can see that we use two components, Apache Spark and a service by AWS that's called EMR. And for those of you who are not familiar with those components, I'm going to talk on them now. So what is Spark? Spark is an analytics engine for large-scale data processing. And as I've shown you, we do have large-scale data processing needs. It's a distributed and highly scalable engine. And it's a unified framework for doing batch, streaming, machine learning, and more. Just so you'll be familiar with a few basic Spark terms. So at first, we have the Spark driver, which is basically your main program or the main entry point of your application. That driver submits work to various executors, which are separate Java processors, or JVMs, running on workers across the Spark cluster. Each executor, as I mentioned, is a separate JVM responsible for running the individual tasks or the individual unit of works. Since we're talking about a lot of resources, we need the cluster manager, which is another component, to be able to allocate all those resources. Cluster managers can be Mesos or Yarn or standalone. And the last point I want to emphasize here is that you can use managed Spark version on public clouds. So for example, AWS EMR, GCP Dataproc, and other services on other public data cloud providers. So what is EMR? EMR is a managed service by AWS that allows you to run Hadoop and Spark clusters. It also allows you to reduce cost by using spot instances, and this is an important point here. So spot instances might be called preemptive instances in GCP and other names on other cloud vendors. Those are basically spare compute resources that your cloud provider can give you with a significant discount on the cost, but it can also take it away at any given moment based on demand. And another thing you need to know about managed services in general and EMR in particular is that it charges management costs, or a small fee for every instance running in the cluster. So running Airflow-based Spark jobs on EMR is rather easy. EMR has built-in official Airflow support, as I showed you in the DAG earlier. So we have the EMR create job flow operator, which basically creates or launches a new EMR cluster for you. You then have the EMR add steps operator, which basically submits a Spark application to the aforementioned EMR cluster. And finally, we have the EMR step sensor that checks if the step succeeded or not. Now, Airflow is open source, as you probably remember, so that allowed us to do two things. It allowed us to fix existing components, like the small contribution we've done by fixing a few things in the EMR step sensor. And it also allowed us to add new components, not necessarily related to EMR, but to data pipelines in general, such as the AWS Athena sensor and the OpenFast hook my colleagues created. So this is all great. However, we wanted more. So we wanted to even further reduce our costs. We wanted to increase the visibility into our systems, and we wanted our systems to be more robust. And now to you, Roy, to explain how we've done that.
Hi, thank you. So I'm Roy, and I'm going to talk with you about Spark on Kubernetes as the platform that enable us to do all of the things that Itai mentioned earlier. So let's explain a bit what is Kubernetes, or is called as K8s. So Kubernetes is an open source platform for running and managing containerized workloads. It includes built-in controllers to support various workloads, such as microservices. and it can be extended with additional extensions called operator to support custom workloads such as Spark, and is also highly scalable. Some basic Kubernetes terminology. So we have the Kubernetes cluster. Inside it, we have the worker nodes, EC2 instances in our case from AWS. We have the pods running on them. The pods are a group of one or more containers, such as Docker containers that run in your application. And we also have the control plane, which managing the cluster, it assigning the pods to be run on the worker nodes, and provides extra cluster managing facilities. We also have the kubectl, which is the K8s CLI. With kubectl, we can see which pods running on the cluster. We can run new workloads and manage the cluster. The term operator exists both in Airflow and in Kubernetes, but it's not the same. In Airflow, an operator represents a single task. The operator determines what actually executed when your DAG runs. For example, we have the bash operator, which executes a bash command. On the other end, we have the Kubernetes operator, which are additional extension to Kubernetes. They hold the knowledge of how to manage and run specific application. For example, we have the Postgres operator, which defines, runs, and manages a Postgres cluster on top of Kubernetes. So Airflow operator is not equal to Kubernetes operator. Another cool feature we use of Kubernetes is the cluster autoscale. So at this stage, we have a cluster with no application running on top of it. So the cluster don't have any worker nodes, and we are paying only for the control plane, which is a very small fee. Now that one application starts running, it gets the pending state. Then a new worker node joins the cluster, and the application is now running. When another application want to run on the cluster, if the cluster don't have enough resources, the other application is also gets the pending state, and the cluster is scaling up again with another worker node. So now we have the two applications running. When the application finished, the cluster is scaled back down, and at this point, we don't have any worker nodes on the cluster, and again, we are paying only for the control plane fee. So Kubernetes in a nutshell. So it's a platform for running and managing containerized workloads. Each cluster has one control plane, 0 to thousands of worker nodes, 0 to tens of thousands of pods, and 0 to tens of thousands applications running concurrently. Kubernetes operator is not equal to Airflow operator, and the Kubernetes cluster can automatically scale out and in. Cool. So back to Spark on Kubernetes. From Spark version 2.3.0, Kubernetes is supported as a cluster manager. This feature is still experimental, and some of the important features are missing. For example, better auto-scaling is expected in future Spark releases through the support of dynamic allocation from Spark. At Spark 3, it's half baked through support of soft dynamic allocation, but it's far from perfect yet. So how can we submit a Spark application to Kubernetes? First of all, we can use the Spark submit script, which is built in with Spark, or we can use the Spark on Kubernetes operator, which is a Kubernetes operator. So in this example, we are sending the Spark Pi example application, which calculates an approximation of the Pi number. We are using the Spark submit script, and in the master flag, we're giving it the address of the Kubernetes API server. Then the Spark submit generates a Spark Pi driver pod definition. It's sending to the Kubernetes control plane. Then we have the Spark Pi driver running as a pod, and this pod manages, creates, and deletes all of the Spark executors. Another way is the Spark on Kubernetes operator, which is a Kubernetes operator. It extends Kubernetes API to support Spark application, and it's built by Google Cloud Platform as an open source project, so it's not officially supported by Google, but it has very large community, and we are decided to go with it. More on it later. So here is how we can send the same Spark Pi application with the use of the Spark Kubernetes operator. So we are writing the Spark Pi YAML definition inside of a custom resource object definition which is a Kubernetes resource. Then we can send it with kubectl, which is the Kubernetes CLI. It's sending it to the Kubernetes control plane. And then the Spark on Kubernetes operator inside of Kubernetes is doing the Spark submit for us, and it launches the Spark Pi driver as pod, and again, this pod is responsible for the executor pods. So let's compare the Spark submit to the Spark on Kubernetes operator, or why the Spark submit wasn't really enough for us. So even though the Spark submit already has Airflow built-in integration, it lacks the ability to do advanced customization to the Spark pods, which the Spark on Kubernetes operator allow us. This means to use node affinity or mounting config maps or volumes. It will be available in next Spark version, but till now it's not supported. Also, easy access to the Spark UI. It's not really possible with Spark Submit, but the Spark on Kubernetes operator creating a Kubernetes ingress definition for each application we are sending to the cluster, so we can get easily to the Spark UI. And also, the use of Kubernetes native tools such as kubectl to submit and view application. So now that we know that we want to use Spark on Kubernetes with the operator and also Airflow, we need to integrate it. On EMR already has official support, but for the Spark on Kubernetes operator, we needed to build one. So we decided to take the road less traveled and build this integration for you. At the first day, we are already opened PR to the Airflow project and start to building it with the community. Fortunately, we had a lot of help from the Airflow committers, and we also, and at a later stage, we also built an integration end-to-end test for this integration, so it will be supported for later Airflow version and other Kubernetes version, and also if the Spark on Kubernetes operator will be changed, we know it with end-to-end test. So thanks a lot for Camille, Kasil, Ash, and Jarek from the Airflow community. They really helped us a lot, and I don't know if it was possible without them. So let's talk about the Spark Kubernetes integration. It consists of a Spark Kubernetes operator, a sensor, and Kubernetes hook. The Kubernetes hook gets the connection parameters from Airflow's Kubernetes connection that has kubectl, which is the Kubernetes connection string, and it has all of the authentication parameters, the address of the API servers, and more. Also a namespace, or if your Airflow already run inside of Kubernetes cluster, and you want the Spark workloads to run on the same cluster as well, you can use in-cluster configuration. Then it creates API client and allows you to create and get Kubernetes custom resource object. Spark application is really, inside of Kubernetes, is a custom resource definition object. The Spark Kubernetes operator gets the Spark application resource definition from file or a variable, then it templates it using Jinja and send it to the Kubernetes cluster. The Spark Kubernetes sensor pokes the Spark application as long as the application state is submitted or running. It completes successfully if the application state is success, or raises exception if the application state is failed. So what have we gained by building this integration? So first of all, official built-in Airflow support. So this integration is now part of the Airflow project, and it will be supported in newer version, and it gets the community to support it. Security, we are saving the Kubernetes credential inside of Airflow connection mechanism, which is encrypted inside the database. Also portability, the use of templated Kubernetes object means that we can run almost the same application both manually and both from Airflow. And it's also Kubernetes native, as Airflow communicates directly with the Kubernetes API. So back to you, Itai.
Thanks, Roy. So, you probably remember this slide. Again, I simplified the ETL pattern, and now we are going to take a closer look on the right-hand side, Doug. So, again, it's running the same application, but now with the operator and sensor Roy mentioned. So, the pattern of our data pipeline from the architecture point of view, but this time with a newer version or kind of revised here. So it's pretty much the same, but we changed the EMR cluster to Kubernetes cluster. This is basically the only change from the architecture point of view. So we had a few major benefits for migrating to Kubernetes. First of all, we observed about 30% cost reduction, which is significant. So, for example, when we're using Spark on Kubernetes, there is no additional cost per instance or a management fee per instance, as opposed to what we had in EMR. We have better visibility. So for example, there's an automatic Prometheus configuration using the Spark on Kubernetes operator we mentioned. And finally, our applications are more robust and more resilient. For example, we can run one Spark job on multiple availability zones. This can be very beneficial when you use spot instances. In terms of the current status and our future plans, so the Airflow integration was merged to master, as we mentioned, on March 2020, and we expect it to be available on Airflow 2.0. It's also planned to be included as a backport package in the next minor Airflow release, which is 1.10.11. We're also planning to extend the new Kubernetes hook we created and possibly migrate the Kubernetes pod operator to work with it. And from our end, we're gradually migrating our DAGs. So it's an Airflow Summit, and we wanted to share a few pro tips with you. Some of you might be familiar with those, some of you are not. So here's a few pro tips from us. The first one is to use Jinja templating. If you're not familiar with it, it provides a DAG developer with a set of built-in parameters and macros, and basically allows you to build more flexible DAGs. Second, you can make Airflow more secured using Kubernetes role-based access control, or RBAC. As per monitoring and alerting, one nice thing we do in production, courtesy of one of my colleagues, is to use the DAGs on success callbacks and on failure callback as part of the default args of the DAG to emit metrics to your monitoring system and to trigger alerts based on those metrics. So for example, if one of our DAGs failed, we get an automatic alert to our Slack channels. And the last one is to basically leverage Airflow's built-in components, so operators and hooks and sensors. Now, if you couldn't find one, no problem. Just build and contribute one. We are certain that the community will be able to help you with it. So going back to the same DAG we started with, or DAGs we started with, you probably have very similar DAGs in your organization. So they are similar, but now they can be different for you. So you too can reduce your costs. You can get better visibility and make your systems more robust by migrating your Spark jobs to Kubernetes and leveraging the easy-to-use native Airflow integration we contributed. So just before I wrap things up, a few things we care about. So Women in Big Data is a worldwide program that aims to inspire, connect, grow, and champion the success of women in the big data and analytics field. There are 30 chapters and over 17,000 members worldwide. Now, everyone can join regardless of gender, so we encourage you to find a chapter near you by just visiting the website. We have a very active tech blog where we try to write about the interesting things we do in the Nielsen Identity Engine. And I mentioned two blog entries here about Spark dynamic partition inserts. Now, these two blogs were actually born or created while Roy and I worked on the Spark on Kubernetes project, and they include lessons we learned along the way. And lastly, for those of you who are already eager to watch the slides again, here's the link, so you can just go to SlideShare using this URL and download our presentation. So that's it for us. Really appreciate your participation, and we'll be taking questions now.
Okay, hey, yeah, it was really nice listening you guys, Itai and Roy. I really learned a lot of things, and I hope that there has been some questions from the audience as well, and they can really use the Q&A session if they have any doubts around it. I can see a question. Okay, so. Okay, this is from Jeremy. I think that can you provide your slide deck to the team? That way, when it gets hosted onto YouTube, we can see both.
Yeah, I posted the URL in the previous slide, but I will also send the URL on the Airflow Summit attendees Slack channel.
Mm-hmm.
So you just go there and download it. I'm actually going to do it right now.
The video will be available later at the Crowdcast, and you'll get a notification in Slack when they do it.
Okay, great. And another question I got on the Slack Airflow Summit channel is about the Spark stability on K8s, like especially about the job failures and how to identify them and recover.
Okay, so I'll take the question. And
Yes.
so as Itai mentioned, we are scheduling our application to Airflow, and we are using the callback, on success and failure callback to get the metric to our monitoring system. So we have the Spark Kubernetes sensor that tells us the application failed, and then it emits the metric to Graphite, and we get an alert in Slack channels. So also you can do retry to Airflow when your application failed. It's another thing you can do.
Okay, nice. And I got the similar, like on the same line, I got another question that how do you measure the 30% cost savings uh, while running a Spark onto Kubernetes? Because that same node would be running some other applications as well. So how do you measure the 30% cost savings?
Okay. Well, I take the first part, and you can add.
Of
So,
course.
so I think it's this is a rather complex question, and it's true. It's a bit hard to measure. So we've done a few things. First, we know what is the additional fee that you need to pay for every instance on EMR. So you can just easily calculate that as against the number of instances, as the type of instances you're using or we are using on the Kubernetes cluster. Second, when we started running applications, So we did it gradually. We're actually doing it gradually. So we first had only one application that was rather easy to measure because only one application was running on the cluster. As we're adding more applications, Roy is currently working on the cost attribution part of this project. And so right now, some things are done manually, right? We use various techniques. Maybe Roy, you can further elaborate, but we use various techniques to measure what we currently have, those few applications that are already running in production. And you know, Roy, you can just jump in.
Okay, so I'll give you an example. So on EMR, if I'm using the i3 8 extra large instance, the spot cost of it is $0.7 per hour, and the additional management cost from EMR is $0.27 per hour. So the EMR management cost is significant, and as you're adding more and more nodes to the EMR cluster, you're paying more and more EMR cost. But on Kubernetes, we are using the EKS, is the managed Kubernetes service from AWS. We are paying for all of the control plane of the cluster, 60 USD per month, flat, no matter of how many instances I'm joining to the cluster. So this is the first significant cost reduction you can do. It really significant. But also we are not using the EMR management instance. It called the master instance. We don't need it anymore. And also as we migrate more and more DAGs, we are using transient EMR cluster. For each step, we have its own EMR cluster, and they're going up and down, and we are paying a lot of money to provision EMR cluster. And on Kubernetes, we are hope that their nodes will be recycled. So for every step, we are not trashing all of the instances and then provision them again.
I think that the last point about this question is that, and this combines a few benefits from running Kubernetes. So from our experience moving those couple of applications that we mentioned, since they are more resilient or more robust when they run on Kubernetes, it basically allows us to not have to rerun them in case they fail, which we sometimes need to do on EMR. So that's another cost decrease, right? When you don't need to rerun your application, you don't need to repay for the cost. So that's everything we talked about kind of adds up to about 30%, and that can be significant, amount of money when we're talking about a few $100,000 per month on AWS.
Okay, I'll just wrap it up about the use of about the use of spot instances and how Kubernetes is more robust. On Kubernetes, we run the same Spark application on multi-zone. So if we get a lot of spot interruption, we can assign new spot instances from other availability zone. So our application has the ability to finish. On the other end, on EMR, some of our application gets stuck.
Okay, great. Cool. So we are getting lots of questions. So I don't know we can answer all of them, but we can try like a couple of more questions. Okay, so
Sure, but on the
yeah.
Slack channel later, someone wants to.
Yeah, definitely. So people who did not get, their answers here, they can of course reach out to the Airflow Summit Slack channel. A couple of questions we can try it here. One question is about the streaming jobs, the Spark streaming jobs. So like, do you guys handle that as well, or is it part of your infrastructure or not yet?
We don't have Spark streaming yet.
Okay. Cool. Another question is about like when you submit the Spark Kubernetes job, and there has to be done a auto scaling, right? And that from the EC2 side, what happened to your Spark job? Does it fails, or it just waits for the machines to come up and get added into that resource pool?
I don't sure if I understand the question, but I'll try to answer it. We are using the cluster autoscaler of Kubernetes, and we have a lot of node groups. So if we can't provision from one node pools, we go to the other, and then go to the other, go to the. We have a lot of options to. We use 4 availability zones. We use different kinds of machine. So the possibility is really low, but if we still can't assign nodes to our application, at this stage it's still manual, but we are changing it to run on demand. So we have our workloads finished for our
Yeah.
clients.
I think that maybe the person asking the question might have meant what happens. I mean, if there is a process of autoscaling, if you need to add nodes, so basically the driver gets allocated, but then it waits. I mean, it doesn't seem like a problem. It's relatively faster on Kubernetes to allocate those additional machines. So I don't think we've seen cases of a Spark job failed because it didn't wait for the more resources added. And also, as we mentioned, because you can kind of recycle instances, meaning you have applications running around the clock. So if one application finished, the other one is probably might be already running or going to start running, and it can leverage the instances that's still on the cluster. I hope that answers the question.
Okay, great. So another question is that about have you guys also explored Levy for external job submits to AMR from EKS?
No.
No. Okay, so that's fine. Maybe the last question is that about the Glue Metastore. So, like, do you guys use the Glue Metastore, or you guys use your own Metastore, or maybe like Hive Metastore,
Yeah,
or
we
some other Metastores?
so.
You guys use Hive Metastore, right? Okay, okay, and yeah, I think the last question is about do you guys tried running Spark on K8s cluster with Fargate instances?
We are not using Fargate instances. Good question.
Okay.
So Fargate instances on EKS is relatively new function, but I think for our scale, so first of all, when you run Spark, it's better that you use NVMe SSD on the instances, so you have a fast disk for shuffle, and in Fargate you need to connect EBS, so it's much slower. Also, Fargate is much expensive than getting your own EC2 instances, so we opted for using EC2 autoscaled with the use of Spot. And also, I can recommend, although we didn't use this product, you can check the Spot company product called Ocean that aims to deal with this question of running EKS cluster, but serverless. I think it might do it better than Fargate.
Awesome. Great. Okay, so I think that's it about the questions, and thanks a lot, Itai and Roy.